Hi, this is Ben Schreiber, and you are watching the third video in the series of 3 for Bubble Sort, the song and code, with rhymed pseudocode lyrics that we will use to code bubble sort in Python. So, let's hear it.
Bubble sort's useful on lists sorted partially, but very often it runs quadratically. It does sort in place and is stable in any case. And since its implementation is so short, why not sing bubble sort? Loop through each index in the list but the last one. If current is greater than next, then swap their positions. If in the loop you swapped at least once, loop again. Otherwise your list is sorted and bubble sort ends.
So I hope you enjoyed the song. Here are the lyrics to it, and we are going to use them to write the bubble sort algorithm in Python. So the first thing I'm going to do is comment out the analysis lines. They're useful for understanding the algorithm, but not as useful for implementing it. Let's just take a look at what's going on here. We have a stubbed out bubble sort function. We have a list of values which we wish to sort. They are in reverse order, and we would like them to be 1, 2, 3, 4 as opposed to 4, 3, 2, 1. So first we're going to print out the list before bubble sort, and we'll just show it as is. And then we're going to print out what bubble sort did to it. Hopefully it will sort it so that it is in the correct order. Okay, so let's take a look at the first line. Loop through each index in the list with the last one. As we're going through the lines of pseudocode, I'm going to insert them in their appropriate place in the code. To do this, to loop through each index in the list with the last one, I'll say for I in range length list of values -1. If you're not familiar with the range function, let's see what it does. So let's call range on 6. It returns what's called an iterable of the values 0, 1, 2, 3, 4, 5. So it doesn't include what's in the parentheses, which is an upper bound. The lower bound, unless otherwise specified, is 0. And if we wanted to supply an upper bound, a lower bound, we would do it like this. So we have a lower bound of 1 and the upper bound of 6, and it's going to return 1, 2, 3, 4, 5. So it starts at the lower bound and cuts off 1 before the upper bound. And now that we understand range a little bit better, let's go back to the code. For I in range len list of values, we're just going to do whatever inside the for loop for each item in the iterable. Now, if current is greater than next, then swap their positions. So if the value at our position I is greater than the value of position I plus 1, swap the values. So we're going to need to make a swap function here. We'll take in 3 parameters, the list, and the 2 indices which we wish to swap the values at. So let's declare swap. I'll call the first index index 1, and the second one index 2. Write a little comment. Here's what we want to do. Store the value at index 1 into a variable called was at index 1. Now we change the value at index 1 to be the one at index 2. So now index 2 and index 1 store the same values. Okay, we want to change the value at index 2 to be the value that was at index 1. And that's all for this. Next line. If in the loop you swapped at least once, loop again. Comment that out. So when we make a swap, we'll set a swapped variable equal to true. So we need to loop while we made at least one swap, so we'll create an outer while loop here. We're going to execute the for loop while swapped equals true. And we're going to do it over and over again as long as swapped equals true. So we need to be able to enter this loop, because if swapped is not created, it won't know what to do with it. And if swapped is false, then we're never going to enter this while loop. So we need swap to be set to true before we enter the loop. Before executing the for loop here, we need swap to be set to false, because we haven't looped through the indices yet. If we do swap, if one of the positions is out of order, then we set swap to true. If we don't make any swaps during this for loop, swap will still be false. When we check back at the top of the while loop, we'll see that swap is not true, and we will stop executing because none of the values are out of order. So otherwise your list is sorted and bubble sort ends. But I think we can try to see if this works now. So it appears as though bubble sort has done the trick and sorted the list of values such that what was 4, 3, 2, 1 is now 1, 2, 3, 4. So now you have a sorting algorithm that you can always pull out of your pocket, which is especially useful if you have a partially sorted list. So I also hope you enjoyed the song, and I thank you for watching.